Well, in this lecture, I get lower than lower, and I'm going to take us to the body of water with the lowest elevation anywhere on Earth, the Dead Sea along the border of Israel and Jordan. Now, the Dead Sea is also one of the very saltiest places on Earth. About a third of the water is actually dissolved mineral salts. Now, I have visited some very high places so far in this course. And a big problem if you actually go visit these is the air gets very thin. It's hard to breathe. I mean, the slopes of Everest are scattered with empty oxygen canisters, and bodies too. This is actually a very predictable phenomenon. You can easily find charts that show you what the air pressure will be as you go up above sea level. These charts all start at sea level, and that makes sense, right? Because you can't go below sea level, right? Wrong. First of all, we've already talked about places far below the surface of the Earth, down in caves. But there are also places you can go to on land where the surface itself is far below sea level. Now, I briefly talked about one of these places in the lectures on the African Rift Valley and Erta Ale, the lava lake, when I talked about the Danakil Depression in Ethiopia being about 100 meters below sea level. Well, it turns out there are several places around the planet where the surfaces of the continents actually sit some distance below sea level. The deepest of all of these is the Dead Sea. The surface and shores of the Dead Sea are 423 meters, 1,388 feet below sea level. And if you visit here, you will be able to breathe more easily than anywhere else because the air pressure is actually 5% more than at sea level. You actually breathe in more air. I talked a little bit about this phenomenon and how it works in the lecture on Gibraltar, when I described what it would have been like at the bottom of the Mediterranean Sea when all the water evaporated and it dried up. However, I have to add that the exact elevation of the Dead Sea below sea level is not constant. Now, if you go there, you will see signs all over the place that will list the elevation below sea level of the shores of the Dead Sea. The funny thing is, if you look at different signs in different areas, they all give you different numbers for the elevation. Well, it's not the case that they've all made mistakes. It's because they were put up at different times. It turns out that the level of the Dead Sea is rapidly dropping, about a meter per year. You can actually see it clearly if you look at the shorelines and the surrounding hills. You can see multiple rings of these past shorelines. And it can still drop a long way. I mean, the Dead Sea is still 375 meters deep. So the record books may have to keep being changed for a while. The Dead Sea is not terribly big. It's about 67 kilometers long, and it's about 18 kilometers across at its widest point. And it sits in a long, narrow valley that stretches all the way from the Red Sea way up north to Syria, and it separates Israel and Jordan. The border, in fact, runs straight down through the middle of the Dead Sea. Now, most lakes eventually drain to the ocean. That's how it works. This obviously can't happen here with the Dead Sea because it's below sea level, and rivers can't flow uphill. Well, okay, they do sometimes if there are tidal bores, like I talked about with a lecture on the Bay of Fundy. I have to be a little bit careful with what I say here when it comes to geology because there are often exceptions to the rule. But it's clear that the water here is not flowing to the ocean. So what happens to the water? Well, there is a main river, the Jordan River, that runs down from the north. It first drains into and out of the Sea of Galilee and then flows down the narrow valley into the Dead Sea. But the Dead Sea is a closed basin. The water evaporates as fast as it enters. In fact, now it's actually evaporating faster than it's being filled because the water from the Jordan River is being largely drawn off for a variety of purposes by Israel and Jordan. There's a very dry climate here. It only rains about 10 centimeters per year. I mean, this is a desert. So rivers flow into the Dead Sea, the water evaporates, and that leaves behind salt? Well, salts really, because it turns out there are many different kinds of salts. The Dead Sea is one of the saltiest lakes on Earth. It's 33.7% salt. That's actually 8.6 times saltier than the ocean. In fact, there are only a handful of places that are saltier. Lake Assal in Djibouti, and one very shallow, less than a foot deep pond in Antarctica. And I'll talk about these two places at the end of the lecture. Now, you can see evidence of how salty the water is by the unusual salt features that have precipitated all along the shore. It creates some really bizarre looking rock formations. Some of them look like small little castles sticking up out of the water. And the salt crystals form on anything there, rocks, sticks, anything that's in the water. But as I mentioned, the salt here is not the same as ocean salt, which is mostly sodium chloride. It actually has a very different taste than ocean salt. You can go to some specialty gourmet shops and buy different salts from around the world. They have slightly different tastes depending on the exact chemical composition in them. You may have noticed already that ocean sea salt, if you cook with it, tastes slightly different than table salt, which is just sodium chloride.